In this podcast, I am going to explain how to find the areas of the basic shapes that we have in the mathematics O-level syllabus. So here we have our first shape, which is a rectangle. To find the area of a rectangle, we have to multiply the length with the breadth. So area is length times breadth. Therefore, in this case, the area is 15 centimeters times 7 centimeters. So the answer is 105 centimeters squared. Now here we have a triangle. In order to find the area of a triangle, we have to multiply the base of the triangle by the height and divide by 2. When we check the height of a triangle, it has to be the vertical height, which in this case is 5 centimeters. So basically we have to take the highest point of the triangle, we sort of draw a line to the base of the triangle, we make sure that this is a 90-degree angle. In this case, this is 5 centimeters, as we have here. So the area is 1/2 base times height. So in this case, the base is 15 centimeters, the height is 5 centimeters, and we divide that product by 2. So 15 times 5 all over 2, the answer is 37.5 centimeters squared. Our next shape is the parallelogram. A parallelogram is basically a quadrilateral, so it's a shape with 4 sides. However, 2 of these sides are parallel and the other 2 sides are parallel as well. In order to find the area for a parallelogram, we use the formula base times height. The height of a parallelogram has to be the vertical height. So if we take any point here, we have to draw a line that is 90 degrees with the other line, and that is the height. In this case, it is 9 centimeters. Therefore, in order to find the area of this parallelogram, we'll have to multiply the base, which is 15 centimeters, by the height, which is 9 centimeters. And the answer, 15 times 9, is 135 centimeters squared. The next shape is another quadrilateral because it has 4 sides. And in order to find the area of this quadrilateral, first of all, we have to identify what type of quadrilateral this shape is. In fact, this is a trapezium. And you know that it is a trapezium because 2 sides are parallel and the other 2 are not parallel. And to find the area of a trapezium, let's say that this side is side A and the other parallel side is side B. The formula to find the area for a trapezium is you have to find the average length of sides A and B of the parallel side. So it's A plus B over 2 times the height or the distance there is between the parallel sides. In this case, it is this that I am going to mark as H. In our case, H is 15. So A plus B over 2 is 21 plus 45 all over 2. And then we multiply it by the height, which in this case is 15. And the answer is 495 centimeters squared. The next shape that we have is the circle. In order to find the area for a circle, and I mean for a complete circle, we have to use the pi. In fact, area for a circle is pi r squared, where pi is 3.142, etc. It's a constant that you can get from the calculator, and r represents the radius, which in this case is 15 centimeters. So to find the area of the circle, we do pi times 15 squared. And we will get the answer 706.86 centimeters squared if we round the answer up to 2 decimal places. The last shape that we have here is that of a sector. Now, a sector is part of a circle. It's like when we have a circle and we take part of it. Whenever we are provided with a sector, we are always given the angle that that sector is doing. For example, in this case, it is 130 degrees. Now, you have to understand that this 130 degrees is 130 degrees out of a whole circle, and the whole circle has 360 degrees. Therefore, the area of a sector is, first we find the area of the whole circle, so it's pi r squared, but then we have to multiply that by the fraction that this sector is representing of a whole circle. And we get the fraction by using its angle. So in this case, it's 130 degrees. So it's 130 degrees over 260. So to write the formula, it's pi r squared times theta on 360, where theta is representing the angle. Therefore, the final answer is pi times radius squared, which is 15 squared, times theta, in this case, is 130 degrees, over 360 degrees. And in this case, the answer is 255.25 centimeters squared if we round the answer up to 2 decimal places.